Hello, good everyone. So welcome back to my YouTube channel again, Gasaligan Vlogs. And today we'll be talking about integration by parts, and this is integral calculus. So stay tuned and watch and learn. So we have integration by parts, I-25. So this is I-25. The integral of u dv is equal to uv minus the integral of v du. So we have to note here that no general rule can be given as to which of the two factors will be u and which will be dv. However, we emphasize that u and dv should be chosen in such a way as to make the integral of dv easy to evaluate. So let's have example number 1 so that we could be able to use I-25. So how to use this part. So integration by parts, we have here integral of x e raised to x dx. So in picking up, so we have to uh, use u as we could be able to integrate dv easy to evaluate. So we have here u is equal to x. I'll pick u is equal to x, and our integral of dv is equal to e raised to x dx. Okay. So next we have here our du is equal to dx, so therefore our v is equal to e raised to x. So the formula in finding the integration by parts is, by the way, the integration by parts is commonly helpful when there are two products of the two functions such as algebraic and exponential. So in this case, this is algebraic and exponential, right? So algebraic and exponential, algebraic and trigonometric, exponential and trigonometric, and algebraic and logarithmic. So there are two functions, or the product of two kinds of functions. So we can make use of integration by parts. So product of two functions, two kinds of functions, which is this part is algebraic and this is exponential. Okay, let's go back. The formula is integral of u dv is equal to uv minus the integral of v du. So integral of, which is our u, okay, integral of u dv is equal to uv minus v du. Okay, so we have here the integral of this part. Okay, so now we have here the integral x e raised to x dx is equal to, what is our u? Our u is equal to x e raised to x, which is our v, minus the integral of v du. So what is our v? E raised to x, and this is dx. So we have here x e raised to x, the integral of this one minus e raised to x plus c. So we have here factor e raised to x minus 1, then plus c. So therefore the integral of x e raised to x dx is equal to this part. Okay, so that's it, number 1. So let's proceed with number 2. Integral of x cos x dx. So first is we have to find for this. What is the value for our u? Our u is equal to x, and our dv is equal to cos x dx. When we integrate this part both sides, so our v is equal to, we have sine x, and du is equal to dx. Okay, so by using of integration by parts, integral of x cos x dx is equal to uv minus the integral of v du. This is uv v du. So x cos x, so what is our u here? X times v is sine x, there is sine x minus the integral of, what is our v? Sine x dx. Okay, so we have here x sine x, and what is the integral of this one is plus negative cos, then negative cos x plus c. So the integral of x cos x dx is equal to x sine x plus cos x plus c. Okay, so moving on with number 3, the integral of sec cube x dx. So here we could factor, okay, we could factor this part. So we have here sec squared x and sec x dx. So what is our u here? Our u, when we pick u, okay, our u here is sec x. Our du is equal to sec x tan x dx. This is the derivative of sec. So the dv, the remaining here is, when you disregard this one, this is the integral of sec squared x dx. So integral both sides, so v is integrate both sides, therefore v is equal to tan x. Okay, now we have to integrate. Okay, so what is our u? Our u is sec x, our v is tan x, minus the integral of v, which is tan x, the integral of du, which is sec x tan x dx. Okay, next we have sec x tan x minus the integral of tan squared x secant x dx. So now we have here tan, you could simplify further. Okay, so integral of sec cube x dx minus integral of sec x. The equivalent for tan is secant squared x minus y dx. So we have here sec x tan x minus the integral of sec cube x plus integral of sec x dx. Since same here, sec cube x and sec cube x here, right? So we have to transpose to the right side, which is 2 integral of sec cube x dx is equal to secant x tan x. See, we have to move here and become 2 secant x x secant cube x dx is equal to sec x tan x minus plus the integral of sec is equal to ln of sec x tan x plus tan x, then plus plus c. So we have here to the, since the question is integral of sec cube x dx, so divided by 2 here, divided by 2. So therefore the final answer is integral of sec cube x dx is equal to secant x tan x plus ln of sec x plus tan x over 2 plus c. So this is the answer for integration by parts. Number 3. Okay, let's have number 4. Number 4, so integral of e raised to negative x cos 2x dx. So what we're going to do here is we need to pick for the u and which is the dv. So again, there is no rule in picking up the u or dv as long as dv could be easily to evaluate. Okay, for this time we have here, we'll let u is equal to cos 2x and our dv is equal to, we have e raised to negative x dx. So we have here du is equal to, when we integrate du, which is negative, alright, we have negative 2 sine 2x dx. And we need to integrate this part. So v is equal to, we have our e raised to negative x negative here. So why is it negative? I will perform here. So because we let our u is equal to negative 1, negative x, and du is equal to negative dx. So therefore our nf here is negative 1. So by simply substituting here, so we could have negative in this side, right? So we have here, we could have the integral of eu du. So what? Okay, so integral of this part, which is e, what is our e here? E raised to u times our du is negative du here. So we have here eu, negative eu plus c. So therefore we have negative e raised to negative x. So that's why we have here a negative sign here in this part. Okay, so we have here, the next part is we have to integrate using integration by parts. So we have integral of e raised to negative x cos 2x dx, which is equal to u v minus the integral of v du. So we have here, let us have first what is our u. Our u is equal to cos 2x, our v is equal to negative e raised to negative x minus the integral of, which is our v is negative e raised to negative x times our du here is negative 2 sine 2x dx. Alright, so this is it. So next we have to perform again. So simplify first, integral of e raised to negative x cos 2x dx is equal to e negative x cos 2x minus, and this will become minus integral of, this is negative negative, so therefore it will become positive. So e raised to negative x, we have 2 e raised to negative x, extract this 2 here, move, then sine 2x dx. Alright, so still we could see that this is still the two product of two kinds. So therefore we have to integrate it by parts again. So in this case we have we have to integrate it by part. We have to copy first this part, negative e raised to negative x cos 2x, which is 2, and by the integration we have to fill in later. So we have to integrate first this part. So integrate e raised to negative x sine 2x dx. So in this case, what is our u? We have to pick our u is equal to sine 2x. So therefore, our integral of dv is equal to the integral of e raised to negative x dx. So our du is equal to, what is sine 2x? We have 2 cos 2x dx. And our v here is e raised to negative, again, negative, same process here, this part, negative e raised to negative x. So now by performing here, we have to let uv. So what is our u? Again, this is sine 2x, and our v is negative e raised to negative x. We have repeated the process of integration by parts. Negative e raised to negative x, then minus the integral of v, which is negative e raised to negative x, which is r du, is equal to 2 cosine 2x dx. Okay, so this is negative, negative, and it will become positive. So we have here integral of e raised to negative x cos 2x dx is equal to negative e raised to negative x cos 2x, and we have to simplify because this is for all terms here. 2. Okay, so negative 2, and this is negative, negative, and this is plus 2 sine e raised to negative x, negative, negative, e raised to negative x sine 2x, and this will become plus integral of e raised to negative x cos 2x dx. And what have you observed here? We have this same pattern with the given here, so we could have the same pattern in this case. So in this case, alright, so we have here times 2, rather we have 2, distribute 2 here, and still we have 2, so therefore this is negative, negative, and this is negative, so therefore this is negative 4 e raised to negative x cos 2x, because negative 2 and negative 2 times negative, positive, and this is negative times negative, that's negative. Since it's negative 2 and negative 2 times 2, that's 4, so therefore we have 4 e raised to negative x cos 2x dx. So next we have to transpose this one to the right side, so we have to combine to a given. So therefore we have here, we have to comment here in this side, so we have 4 and this one will become 5. So therefore we have 5 integral of e raised to negative x cos 2x dx is equal to negative e raised to negative x cos 2x plus 2 e raised to negative x sine 2x. Okay, so after that one, we have to combine. So divide all terms by 5. So integral of e raised to negative x cos 2x dx. We have to divide it by 5, all terms here. And this side also we have 5. So the remaining is negative e raised to negative x cos 2x plus 2 e raised to negative x sine 2x, or over 5, and plus c. Okay, so we have to extract the common, which is e raised to negative x. So therefore we have here the integral of e raised to negative x cos 2x dx is equal to e raised to negative, this is negative. Okay, so this is negative e raised to 2x. So this is e raised to 2x okay, we have to extract in this part, and this part you have to recall that this is e raised to negative x, and this is negative and negative. Okay, negative and negative, that is positive e raised to x, and this is positive, so therefore we have the answer e raised to negative x over 5. Extracting this part, we have 2 sine 2x minus cos 2x. Okay, then plus c. Okay, we have here plus c. So this is the final answer. So again, integral of e raised to negative x cos 2x dx is equal to e raised to negative x over 5, 2 sine 2x, 2 sine 2x minus cos 2x plus c. And that is for number 4. So moving on to number 5, which is the integral of inverse tangent of 2x dx. So first thing is we have to let our u here is equal to inverse tangent of 2x. And if you're going to take the derivative of this one, du over dx is equal to, we have 1 over 1 plus u squared times du over dx with respect to x. So what is our u here? Our u in this part is tangent 2x, which is u is equal to 2x. Our du is equal to 2 dx. Okay, so therefore our nf is equal, no, not nf because we're not integral. So u is equal to 2x, du is equal to 2 dx. So therefore, by simply substituting here, so we have du over dx is equal to 1 over 1 plus the u is 2x squared, and the du, derivative of du is equal to dx. du over dx is equal to 2 here, because we can have du over dx here is equal to 2. So next we have the result is du over dx is equal to 2 over 1 plus 2x squared. Alright. Next we have the integral. So the next is the integral of tangent negative 1 2x dx is equal to, what is our u? Our u is equal to tangent negative x 2x. By the way, we have to find first our dv. Integral of dv is equal to the integral of dx. So our v is equal to x. Our v is equal to x, so therefore uv, that is x, minus the integral of v du. Okay. Okay, v du. So we have here the integral of tangent inverse tangent of 2x dx is equal to x tangent inverse tangent of 2x minus the integral of what is our v is x, and our du here is equal to, we can transpose this part, it becomes du is equal to 1 over 1 plus 4x squared 2 dx. So therefore, so this is our du. So this is 2 over 1 plus 4x squared dx. So by taking here the tangent, so we have here x inverse tangent of 2x right? Inverse tangent of 2x minus, we have 2x dx over 1 plus 4x squared. So next, we have to integrate this part. So by letting u is equal to 1 plus 4x squared, our du is equal to 8x dx. So therefore, we have to neutralize it. We have here 1/8. So by neutralizing factor, so we have 1/8. So since this is 2, we have to extract here. Okay. So the integral of tangent, inverse tangent of 2x dx is equal to x inverse tangent of 2x minus 2, and with the nf, which is 2 over 8, the integral of x dx over 1 plus 4x squared, which is the equivalent of this one is equal to, this is du, and this is our u. So therefore, integral of inverse tangent of 2x dx is equal to x inverse tangent of 2x is equal to 1/4 minus 1/4, and this is du over u, this is ln of 1 plus 4x squared plus c. So this is the final answer for number 5. Alright, so at this point of time, so you have to try this at home. Integrate by parts to evaluate the following integrals. So x cos squared 2x dx and our 2x e raised to x dx over 1, the quantity of 1 plus 1 plus x squared, and the integral of sine ln x dx. So thank you so much for listening, and please don't forget to subscribe the channel. Thank you, and once again, good day.